Hey guys, just making a quick video here tonight, just to kind of cover what ions are. All right, you're going to be hearing that word a lot, ions, especially throughout the rest of your uh, schooling career. Okay, seventh grade, eighth grade, all throughout high school, college. If you go to college, okay, you'll be hearing that word a lot, ions. And this video, I just want to talk about what ions are and try to keep it as simple as I possibly can. Okay, and a few things that we're going to have to remember as we kind of launch in here through this video is all matter. Okay, so matter being anything that has mass and anything that takes up space or would be considered volume. Okay, anything that has mass and volume is considered matter, and all matter is made up of things that we call atoms. All right, and we remember that atoms are really made up of three different particles. Okay, one being protons, which are positive. So I use a plus sign there, right? Protons are positive. I remember that because proton and positive both start with a P. Okay. We also have electrons. Electrons are going to be negative. Or electrons are those guys that kind of buzz around the outside of the nucleus of an atom. So those are the things that are constantly moving. And then the third thing we have is, I guess I gotta stand, is neutrons. And neutrons are neutral. I'll always just kind of use a circle for that. Neutrons are neutral, they don't have a charge. And what we've done in the past, over the last week or so, when we're making our Bohr models, okay, remember those are just representations of what different elements would look like. When we're drawing Bohr models, we always say that the number of protons and electrons is the same. That's because we want our atoms to not be positively charged or negatively charged. We want them to be neutrally charged. But that is not always the case, okay? There's going to be times where we're going to have atoms that are positively charged. We're going to have atoms that are negatively charged, meaning the number of protons and electrons isn't going to be the same, okay? Um, so we're going to kind of get into that a little bit, okay? So real quick, first example I want to talk about would be lithium, and I have it up on the board as you would see it on the periodic table, okay? So up here we have our atomic number, okay, which is 3. So I'm going to just go ahead, I'm going to get right into a Bohr model to help you visualize this real quick, okay? So atomic number is 3, so that means we're going to have 3 protons, okay? And we've also talked about to find out how many neutrons something has, you want to find the difference between the atomic number and the atomic mass. And right here, our atomic mass is 6.941. We don't want to deal with decimals. It's not really good. Okay, so what we do is we take a look at the number in our tenths place, and that number in the tenths place is going to tell us to round up to 7 or say it's 6. So you want to round to the nearest whole number. Well, 6.9. Okay. 9 is going to tell us to round up. So we're going to go ahead and we're going to pretend that our atomic mass is now 7. To find out how many neutrons we have to find the difference between these two numbers. So what's the difference between 3 and 7? 7 minus 3, well, it's 4. Okay, so that means we're going to have 4 neutrons. I'm going to put those in here. And then we're going to go ahead and there's our nucleus. We're going to go ahead and plug in our electrons now. And like I said, when we talked about this over the last few weeks, we've said we want the number of protons and electrons to be the same. Okay, we want this to be balanced, right? If we have 3 positively charged things, we want 3 negatively charged things to cancel them out, cancel each other out, okay? So I'll fill in, well, I guess since we have 3 protons, we should have 3 electrons, right? So our first ring, if you can remember, can hold 2 electrons. So once we fill that first ring, or first shell, we're going to have to go to a second one. And the second one can hold 8, but we're only going to need to use 1. Right? So if we take a look at this right here, we have 3 protons, 3 electrons. This guy right here is nice and neutral, nice and balanced, okay? However, this isn't always realistic, okay? It's not always going to be balanced. There's going to be times where we're going to have either more electrons than normal or less electrons than normal. Lithium is always going to have 3 protons. Okay? If lithium loses a proton, so it only has 2 protons, its atomic number is now 2, and that means it would be helium now. Okay? If it were to gain a proton, that would mean it has 4 protons. Its atomic number is now 4. Which element has an atomic number of 4? Beryllium. Okay, so this would become beryllium. If you change the number of protons in an atom, you're changing the element. You're changing the type of atom that it is. Okay, so when we're talking about ions, really what we're talking about is more or less electrons than normal. All right. So if I were to go ahead and add an electron to lithium, well, now I have 3 protons, 3 positively charged particles, and 4 electrons, or 4 negatively charged particles. Okay, so 3 positives, 4 negatives. Well, if it sounds like to me it has 1 more negatively charged particle than positively charged particles. So if I wanted to write this, lithium would be Li, but it's going to be negatively charged, right? Because it has more negatively charged particles. So I would just write Li with the negative sign at the top. Okay, so this denotes to me that we have a negatively charged atom of lithium. Okay. Now we can kind of do the opposite here. Let's say, so again, we're going to keep our 3 protons in the center. Let's say we take an electron away. Okay, so instead of having 3 electrons, now we only have 2 electrons. So we have 3 protons, 3 positively charged particles, 2 electrons, so 2 negatively charged particles. Well, now we have one more positively charged particle than negatively charged particles. So lithium now is, in this case, it would be positive. So I'll write a positive sign right there. Looks like an X, but that's a plus sign, I promise. Okay, so I'd write Li plus. Okay, so that would be lithium. And again, I want to make sure we get this written down here. Ion. This is a positively or negatively charged atom. So anytime that the amount of protons and the amount of electrons is not the same, we're going to have an ion. Okay, because they don't have an equal charge. All right, I'm going to go ahead. I'm going to clear this off real quick, and we're going to talk about hydrogen. Maybe I'll keep everything except this Bohr model I have down here. All right, this is using a paper towel, so this isn't erasing very well. Oh well. My phone out of here. Okay. So now we're going to talk about hydrogen. Okay. As you can see in the top corner of my board there, I have it as you would see on the periodic table. So hydrogen, it has an atomic number of 1, so that means it's going to have 1 proton. Okay. If it has 1 proton and we want this to be balanced, it's also going to have 1 electron. So I'll make my ring 1 electron. Okay. And then we need to find out how many neutrons it has. Well, its atomic number is 1. Its atomic mass is 1.008. And if I were to round that to the nearest whole number, 1.008 just rounds to 1. Okay? What's the difference between 1 and 1? Nothing. 0. So hydrogen actually has 0 neutrons. Okay? All hydrogen is, it's a proton and an electron. All right? Now we're going to stay on track here with talking about ions here. If I were to go ahead, and I guess I'll start by writing our H here, write our element symbol, H. Sometimes what's going to happen, and this can happen quite often, is hydrogen is going to lose that electron. Okay, it's going to lose an electron. And all we have here is just a proton, okay? So right here we have 1 proton, 0 electrons. So that means we have a positive charge of 1. So hydrogen, in this case, this ion of hydrogen would be H positive, okay? This is a positive ion of hydrogen. In this, actually, if something's considered an acid, okay, so like vinegar or like lemons have like citric acid in it, um, sour candy, okay, anything that's sour, anything that's considered an acid is made up of positive hydrogen ions. Okay, so if something's an acid, what makes something an acid, what makes something sour to the taste, is all of these hydrogen ions. And if you look at it, what's a positive hydrogen ion? It's just a proton. Okay, so what's really interesting to me is when I'm drinking lemonade and it's sour, really what I'm tasting is protons. Okay, if I'm eating sour candy, like say I have like lemon heads or something like that, what I'm tasting, that sour taste, is protons. All right, so I don't know. I always find that really interesting. But that's ions in a nutshell. And then I'm also going to go ahead and we'll write this down on the board. Okay, acids. Acids. Those are anything that make positive hydrogen ions. All right. Sweet. That's all I got. Sorry, this video went a little bit longer than you probably would want, but well, it is what it is. All right. Thank you guys for watching. We'll talk to you guys later.